Hello everyone. In this session we are going to discuss about the manufacturing process in short. We can also say manufacturing flow in short. So we'll come from the first procedure. The first procedure will be the design part as a PCB designer. So we are going to design the PCB. The process begins with the creation of PCB layout using computer aided drawing. So the computer aided drawing is where we are going to create the schematic part. So we are going to create the symbols, we are going to create the footprints, and then we are going to create the PCB board, and then do the placement, and then do the routing. So all comes under the computer aided drawing design software. So the designers, as we are the designers, we define the placement of the component, we do the routing of the component, and we trace all this and other specification. So the first part is the design. So once you're done with the design with the computer aided drawing, the second part will be the film generation. So once you finish the film generation, so once you finish all your design with respect to the IPC standard or whatever standard you are following, so once you finish it, once you finish your schematic preparation, once you finish your footprint preparation, and then the board design preparation, the board designing is done, then we will create this layer wise or film wise generation will be created. We usually often call it as the Gerber generation. So the Gerber generation will have the files or the films required to do the manufacturing. So these are the file. We call it as film generation. The PCB design, the data is used to generate the films. The films are essentially the negatives of the PCB layers, including the copper traces and other features. The copper traces are like, if I say copper, it will be like routing files, it will be like planing files, and it will be like solder pads. We can also call it as pins, that is SMT pins or through hole pins, and then wire pads. So these are all related to copper. Once we get the films of all the copper negative films, so then we can etch accordingly. So along with that, we also need the solder mask related files, we also need paste mask related files, and then we also need the silk related files, silk screen files. So using these files we will generate the film generation or Gerber generation, so that manufacturer will be able to generate a proper manufacturing or PCB manufacturing. So this is all about the film generation. Second point is film generation. The third point here is the substrate preparation. Substrate preparation. In the substrate preparation, the base material, so often fiberglass reinforced epoxy that we call, it is known as FR4, which is cleaned and prepared, and it may come in sheets or it may come in planes depending upon the intended PCB size. So whatever the size of the PCB, so we need to prepare the substrate, which is FR4 material. On top of it we do the copper cladding. So the next procedure is the copper cladding procedure. So then the copper cladding, the thin sheet of the copper foils are laminated onto the both sides of the PCB. So as we have already discussed about this, so if you have the laminate or the substrate on top of the substrate and on bottom of the substrate, so the thin copper will be placed on top and bottom also according to your requirement, according to your design requirements. So this is called copper cladding. So this will be presented on the top of the PCB and on the bottom of the laminate or substrate. So this is called copper cladding. So once you're done with the copper cladding, so we go for photoresist applications. Just note it down. The persist application. That this is the layer of the photoresist material is applied on the copper surface. The photoresist is sensitive to light, and this will undergo the chemical change when it is exposed. So for example, I'll just take you to the top view section. For example, this is the top view of the PCB. So here on the top layer you will be having the entire copper. So the photoresist is, I will take the photo of your print or your design. For example, I have done the routing this way. For example, I have done the routing. So that particular photo will be taken, and which is pasted on top of the PCB. This photoresist application, this layer is very sensitive to light. So whenever the light is passed on it, so it goes under the chemical change. So what is our motive here is, except this blue color, apart from, for example, this blue color is your circuit, and I just want that particular copper will be printed on top of the PCB, and unwanted copper I just wanted to remove it from this. So we will do the photoresist application. So I will take the printout of my routing and the solder pad which I have on the design, and I'll place it on that particular copper cladding laminate, and then we'll expose it to the UV or ultraviolet light. So the next procedure here will be the ultraviolet, or you can also call it as exposure. So once we expose with the ultraviolet light, so the PCB is exposed to ultraviolet light through the film negative, so transferring the PCB design onto the photoresist. The area exposed to light, so here the area exposed to light is all yellow color is our copper which is exposed to UV light. So whatever the copper which is exposed to light, that becomes either hardened or softened, so depending upon the type of the photoresist which we use. And then later we do the development. So the unexposed photoresist, here the unexposed photoresist is the blue color or the blue thing. For example, this is unexposed photoresist and this is exposed. Okay, so the unexposed photoresist is then removed in a developing solution, so leaving behind the hardened photoresist that corresponds to the desired copper traces and features. So this will become very hard, and the yellow color is completely removed, and the copper which we left is just below the blue color. So that is very hard, and this process is called the development. And the next one is we do the etching process. Etching, here the PCB is submerged in an etching solution, so we put it under the etching solution, which removes the unprotected copper which is exposed to the copper which is open or exposed to the UV light will be removed. The remaining copper traces are those covered by the hardened potential.